can post it online so that if you're not here, I'm going to try to get in the habit of doing this more regularly so that if you don't make it to class someday, there's a video lesson that you can take a look at. I'll be adding it to my YouTube channel, which has maybe 3 subscribers. Yeah. Oh, thanks. 4. Yes. Okay, there we go. So yeah, you could all subscribe and we'd have like 28 plus 3, 31 subscribers. I'd start making money. No, I wouldn't. At 31? I don't think so. Oh, it's viewers. Okay, so yesterday we talked about how we can name the sides of a right triangle relative to an angle. So that's what's showing up here in these diagrams, where if I'm picking angle A is my reference angle, so that's what I'm referring to, then opposite side is going to be the farthest one across from it. So there's my opposite side. That's A, so my opposite side is the farthest one. If that's angle A, my opposite side is that farthest one. Okay? Opposite, fairly easy to recognize. Hypotenuse, also pretty easy to recognize. That's not named relative to the angle A. That's going to be named relative to the right angle. I'll get them later. Keep your attention over here. So hypotenuse, opposite the right angle. Hypotenuse, opposite the right angle. Hypotenuse, opposite the right angle. And then the third side is the one that's sometimes confusing. And so we'll just go with adjacent side, which means beside. So if you're adjacent to somebody, it means you are beside them. Or where else does it show up? Oh, I can't think of a good example. Anyhow, you probably heard the word adjacent come up in conversation at points in your life. Okay, so that's the first thing we need to be able to do. Cheyenne, you're with me? Excellent, thank you. Then we looked at the ratio of the vertical side to the horizontal side here. And this ratio we found is the same for all these triangles because what do we call these triangles? They are what? They're all similar triangles. Yep. And similar triangles, that idea is the foundation of trigonometry. Karin, here's some notes. And I summarized the idea here by saying, oh, in any triangle with an angle that's this big, however big that angle is, the opposite side over the adjacent side, so the vertical over the horizontal, that ratio will always be 1.5, which means the opposite side is 1.5 times as long as the adjacent side. Okay? Then we got onto this page. And on this page, we just looked at the sides and calculated the ratio of opposite over adjacent. And depending on whether we were looking at angle A or angle B, the opposite and adjacent switched. Okay, so those sides are named relative to the angle. So for angle A, this would be my opposite side. So there I have adjacent because that's talking about B, so let's take that off. So for angle A, there's my opposite side. This is my adjacent side because it's beside the angle A, but it's not the hypotenuse. Okay, so opposite over adjacent was 5 over 8, and we put it in our calculator to find a decimal value for it. Okay, typically with trig, we're looking at decimal values. Sometimes we don't, but often we do. Good? Questions? So far, we're all right. Okay. Then we did some plugging in angle measurements into our calculator. So if I plugged in the tangent of 14 degrees, I got about 0.25 when I rounded it to the nearest tenth or 100th, which means that in any triangle where I have a 14-degree angle, the side that's opposite, so here's my opposite side, compared to my adjacent side, the opposite side is always going to be 1/4 as long. And so here I put one example up. So if the adjacent is 4, the opposite would be 1. Suppose the adjacent was 12. What would the opposite be? Tell your neighbor. How long would the opposite side be if my adjacent were 12? Oh, you weren't here either. Yes, you can. Welcome. Okay, who can help me out? Opposite side will be how big? Hadid? 3. Yep, because 3 is 1, not half, 1/4 of 12. So it says 1/4 is long. So I don't have to know the length of any side. This is just giving me the relationship between the side lengths. Okay. And then we looked at the same idea for a 64-degree angle. I think that's where we stopped. So today, what is a function? So functions come up in chapter 5. Yeah, I think chapter 5 will talk about functions. But it's helpful for us to understand it here. Hadid. Thank you. I do have a seat available at the front. Oh, okay. But it's going to be helpful for us to understand the idea of a function at this point already. So the stuff that I'm going to pull out here, you don't have to write down. We're going to come back and review it later. And some of it we'll put on the next page of your notes anyhow. First thing, a function receives input. Okay, here we go. And sometimes I like to draw a diagram to represent a function. And here is Mr. Wagner's fine function machine. Isn't that beautiful? Oh, thank you. So what happens is there's some input, I can spell, put, that goes into the top of my machine, and then at the bottom here I get some output. Okay, so that's the next thing that's a characteristic of a function. It does something to the input, so that's that inside part. So here it does something. Do something. Something. I will spell it ridiculously. Spell it do something. Okay. After it does something, then it's going to give me some output. There we go. Okay. This much isn't a function. This much is actually a relation, which we talk about in chapter 5 as well. The key thing about a function is that the output is predictable. In other words, given one thing is input, there's only one output I can get. So that's what a function is. So to give a couple examples, if you have a bubblegum machine and there's a whole bunch of different colors, you can put in a coin and you know you're going to get bubblegum out, but you don't know what color. So in that sense, we'd say it's not a function because the output isn't predictable. But if you have a juicer machine and you stick oranges in the top, what are you going to get out the bottom? Orange juice. It has to be orange juice, can't be anything else. So we'd say that is a function because the output, there's only one possible output I can get for the input that I put in. Okay, with that, here we want to fill in a few things in your notes. So have your pencil ready. A function operates on an input to give an output. And sorry, the alignment's out of whack because Smart Notebook updated their software and I haven't updated my notes. Need to fix that. Okay, so function operates on some input and it's going to give me some output. So here we have some examples of functions. Y equals the square root of x. So in math, often we write a function as an equation that has y equals and then something with x's on the other side. Don't have to look like that, but that's a common way we do it. So we would say that x is the input that goes into my function. And the value of that square root of x, whatever that is, that's going to be my output. So for example, if that were my function, and here's my function machine, so this is square root. If I stick a 4 in the top, what am I going to get out the bottom? 2. There we go. Okay, so we'd say if 4 was my input, then 2 would be my output. If 16 was my input, what would my output be? 4. There you go. You get the idea. The next equation, also a function. So in this case, I'm going to put x in the top, and then what's going to happen is my function is going to double it, and then it's going to subtract 7 from it. Okay, so my input is x, and the value of this 2x minus 7 is my output. So suppose in this function, I stuck in a 6 as input. What would my output be? 6 times 2, 12, minus 7, 5. Yep. So if I stuck 6 in here, I would get 5 out there. Okay. Trigonometry, like tangent, we would also say is a function. And once again, x is going to be my input, and the value of tan x is my output. But remember, tangent of x is a ratio, right? So it gives me a ratio of how does the opposite side compare to the adjacent side. So the input for a tangent function is an angle. So we put an angle measurement in, and for this course, we'll always stick it in with a measurement in degrees. And then the output we get is a ratio. And the ratio is going to be how does the opposite side compare to the adjacent side. Okay, so it's going to give me that ratio, that comparison. So just to show it in a different way, tangent operates on an angle, and it gives me this ratio as output. Okay, so far we're good? All right. Now we want to talk about what are called the inverse of a function. So an inverse operation undoes what another operation did. So if I multiply, what would its inverse be? What undoes multiplying? Dividing. If I square root something, what undoes square rooting? Squaring. So how do we undo tangenting? We call it inverse tangent. And we indicate it with a little -1 exponent after the tangent. So because inverse tangent undoes what a tangent did. A tangent took an angle as input, gave me a ratio as output. Inverse tangent takes the ratio as input, and it gives me an angle measurement as output. So, yesterday we looked at this Clausenland question where we were given this 70-degree angle and we built this similar triangle where if this was 100, we wanted to know how tall this was. So using similar triangles, we said, well, let's make this 100 millimeters long using the ruler that I had up here, and then measured how long that was. And our measurement gave us 275 millimeters, but with similar triangles. If this was meters, that would also be meters. Okay. The next question that we didn't get to at all is this one, where Mr. Clausen says the tower isn't tall enough, it has to be taller. And he wants it to be 400 meters tall. So then we know, oh, this is 400 meters, that's 100 meter. What angle is going to give me that? Inverse tangent is what's going to tell me that. Because inverse tangent, so tan to the -1, is going to take that ratio as input, and I know relative to this, so that's going to be my opposite side. This will be my adjacent side, and we can plug them in, and it's going to give us an angle. So the opposite, 400, adjacent, 100. What's the angle? Plug this into your calculator and see what you're going to do. So to do the tan to the -1 inverse tangent, you probably have to do a shift or a second function. So you'll do second and then the tangent button, and then put this in. You might need brackets, and hopefully it's going to give you an angle measurement out. I'm getting 79, no, 79? What did I get? 75.963. Is that what you got? 75.963, which will round to 76 degrees. Usually we'll round it to the nearest degree. Sometimes we may ask for the nearest tenth. Sahaj, who's not talking right now. Thank you. If you're not getting this, put up your hand, and I'll come around and help you out. Okay, so everybody was good with this one, figuring out 76 degrees. So let's come back to where we left off, which was the next page. Okay, so as we look at these examples, so some of you already did this, but again, we want to do inverse tangent of 2.05. Ooh, I bet that'll be 64 degrees. Are you getting 64 degrees? How did I know that? No, because I remembered what we did in an earlier question. Remember this question here, we said, what is the tangent of 64 degrees? And we found it was 2.05. So I just remembered that we had done this question earlier. So what it did was it worked backwards. Here, the tangent of 64, we plugged in our calculator, we got 2.05. If I want to work backwards, then I plug in this inverse tangent of 2.05, and often brackets are going to be important, so safe idea to put in brackets, and then we're going to get this is equal to 64 degrees. Good? Hyman, you getting this down? Good. For these next questions, I'm told that tangent of G is equal to 1.782. Let me show you what we're actually doing, and then we'll do some shortcuts and not show every step. Kind of like last semester when we reviewed solving 2x plus 1 equals 8, I would ask you to show all the steps. So showing the steps means I do an inverse operation, undo adding by subtracting. And then I undo multiplying, inverse operation, by dividing. And I end up with x is equal to 7/2. So I'm going to start by showing you the picky details, kind of like this. And then I'll tell you how much I expect you to show me on a question, on a test or a checkup. Okay, so what we're doing here is I have this tangent of G equals 1.782. How do I undo tangenting? I inverse tangent. So what I do is I say I'm going to do the inverse tangent of this tan G. If I do it on the left, I have to do it on the right also. So I'm doing the inverse tangent of both sides. If I do the inverse tangent of a tangent, they just undo each other, and so that just gives me G. And then I calculate this on the right side by plugging it into my calculator and saying, oh, what is the inverse tangent of 1.782? Let's see. Inverse tangent of 1.782 is 60.7 raised to the nearest tenth of a degree, so 60.7 degrees. Yes? Okay, so a couple corrections, just clarification in the language. This is not multiplication. So it's not tan to the negative 1 times 1.782. It's the inverse tangent function operating on this 1.782 to give me an output. Okay? And what you did is as much as I expect you to show me. Okay? So what I'd like you to show me is, first of all, this inverse tangenting of the tangent, I don't expect you to show me that. It's good to understand that that's what's actually happening, but you don't have to show me. You just have to show me, in this case, G is going to equal inverse tangent of 0.509. So actually write that down, and then tell me, oh, what does my calculator tell me that's going to equal? So I'll plug it in and work it out. Inverse tangent 26.509. Enter. 26.97, which will be 27.0 degrees if I want it to the nearest tenth of a degree. Because 0.97, the 7 tells me you round the 9 up to a 10. Oh, that 10 means I round the 1s up from a 6 to a 7. Questions? Okay, I'm going to give you 30 seconds. Check in with your neighbor. Ask a question if you're unclear about something. Okay, now is there a question for me, or are we all good? So far we're good? Okay. We want to find the measure of each angle to the nearest degree. So we could pick angle A or angle B as our reference angle. It doesn't matter for this question. So anybody have a favorite? Oh. Okay, let's go with A. Relative to angle A, here's my opposite side. Here's my adjacent side. So what I can write down is tangent of A is equal to opposite over adjacent, which means tangent of A is equal to 15 over 8. We don't put the units in typically when we're going to write the ratio like this. How do I undo tangenting? Inverse tangent. So that'll be my next step. A is equal to inverse tangent of 15 over 8. If you want to already write that as a decimal value, that's okay, but just like we did in the first semester, no rounding. You need all the decimal places in there. Okay, so we don't round until the very final answer. Oop, and I forgot the -1 in the exponent, so remember that. Inverse tangent. And then I'll just plug it in my calculator. If you have the decimal already, that's great. If you don't, you can type it in as a fraction. So I'm going to do inverse tangent 15 divided by 8, close the bracket, 61.9, which will be 62 degrees. Good. How big is angle B? I'd like you to figure it out. How big is angle B? Okay, so what I wrote on the board is I renamed the sides relative to angle B, and I did tangent of B is 8 over 15. Inverse tangent, we get 28 degrees. Some of you didn't do that. What did some of you do? Hyman, what did you do? Did it somehow. You don't know how you did it? Oh, okay. Hadid, sounded like you did it differently as well. Did you do it you did it this way? Well, something we have known for years is what do the angles in a triangle add up to? 180. And we know this is 90 degrees, right? And I just figured out this was 62 degrees. So I could have just said, oh, angle B, 90 degrees minus 62 degrees, 28 degrees. So we can still use that for answering questions. To find the first angle, we couldn't do that because we only knew one angle. To find the first angle, we had to go through this process. What do I expect you to show me? Okay. For now, and for the checkup on Friday, I'd like you to show me that you know what the tangent ratio is equal to. Write out tangent of the angle equals opposite over adjacent. This can feel tedious, but we're learning, and I want to make sure that you're getting this reinforced in your head. Show me the ratio of the numbers that you're plugging in. Show me how you're using the inverse tangent, and then give me the final answer. At this point, if you put in the decimal number, that's okay. So this could be decimal, or it could be as a fraction. But again, because we're in school, I want to reinforce the process. I want you to show me these steps. Yep.
For the third step, why is it tangent? How would it be tangent?
Okay. Can anybody else answer the question? Why is this tangent to the -1 and not just tangent? Indeed. I'm inversing it, but why am I inversing it? Yeah, so it's coming back to this idea up here. Tangent operates on an angle. I don't know what the angle is. Inverse tangent operates on the ratio. I do know what the ratio is. If I want to find an angle, I do the inverse tangent. If I want to find the ratio of the side lengths, I use tangent. Does that help? Okay. All right. That's it for 15. Next page. Check your understanding questions. So try these. While you're working on these, I'll come around and give you a handout with some more practice. We're going to continue on. So please flip the page to 2.2 in your notes. And rather than do these as a warm-up, we'll just do them together as a review. First thing, though, thank you for your attention, is this terminology. If you have an angle of elevation, elevate means to go up. Okay, so angle of elevation from horizontal measures upwards. Angle of depression from horizontal measures downwards. Okay, so these phrases are going to show up in questions, and we need to understand what they mean. So definitions are here for us to refer to. We'll talk about that in some questions later. First question here, we solved equations like this last week. If I want to know what x is, what do I do to solve? Put up your hand to help me. Semi. I do what? Right now, the x is divided by 15. How do I? Yeah. So I'll multiply both sides by 15. On the left, they cancel out. On the right, I get 45. Good. Number 2, what do I do? Hadid? I could multiply both sides by x, so that's one option. What's another option that we did? Below? Yeah, I could flip both sides. So let me do that just as a reminder. We think of this as being a 3 over 1, and then I flip the left side and I flip the right side. So Hadid, your suggestion, perfectly fine. Yep, we can do that. But I just wanted to remind you that this is an option to take the reciprocal of both sides. Do whichever way makes the most sense to you. Now it's going to be like the first question where I undo dividing by 15 by multiplying both sides by 15. And we get x equals 5. Good? You got this down? Bilal, did you write this down? Oops, Bilal's over there. Nasser, did you write this down? You should write this down. Number 3 is just like the questions we did already, so I'm going to skip past it so we get to the new stuff right away. Here we go. This time, I want to find a side length. And I know this angle here is 35 degrees, so relative to that side, I should say angle, I'm going to name the sides. This will be opposite. This will be adjacent. So then I'm going to remind myself that the tangent of an angle, we're not given any letters here, so I'm just going to pick a letter like A. So I'll call this A. That's going to be opposite over adjacent. And then I can fill in the numbers that I know. Tangent of 35 degrees, because I know my angle measurement now. Opposite side, I don't know. Adjacent side, 17 centimeters. How do I get the x by itself? Hadid? I'm not going to cross multiply. You could, but instead, just like the question we did earlier, I'm going to undo what's being done to the x. It's being divided by 17, so I'm going to multiply both sides by 17. And then I can just plug it into my calculator to find out, oh, what is this 17 times tangent 35 equal to? Again, if you want to change that tangent 35, calculate it as a decimal, that's okay. But remember, you have to keep all the decimal places. I'm just going to plug it in all at once in my calculator and say, what is 17 times the tangent of 35? And it tells me 11.9. But remember, my side lengths had units, so I need to stick in the units. There we go. So this lesson is all about calculating side lengths. Previous lesson, we calculated angles. Now we're going to figure out side lengths. Questions? Nope. Let's do the next one. This time I have a 50-degree angle. So notice I'm not writing down tangent of A equals opposite over adjacent. So at this point, I'm going to say, hopefully you know that well enough. You have to memorize it. It's not on the formula sheet. And then I can say, well, relative to my 50-degree angle, here's opposite, here's adjacent. You have to be really careful with that. So now I have 8 over x. So this is like question 2 where the variable's in the denominator. Hadid's suggestion was multiply both sides by x. Perfect choice. That'll work. Or what we did in question 2, what I wanted to remind you of, is I could think of the two sides as fractions and I could do the reciprocal of both sides. So now it's a tricky thing because I'm getting the tangent in the denominator. So my right side will be x over 8, left side 1 over tangent 50 degrees. Again, if you want that as a decimal already, you can do it. But I'm going to leave it like that because I don't have a calculator right in front of me, and I'll undo this divide by 8 by multiplying both sides by 8. And the 8 gets multiplied to the numerators, cancels out on the right. So I'll have 8 divided by tangent 50 degrees. And that's what I'm going to plug into my calculator. Again, as I've said, if you want to figure out the decimal value earlier, you can do that. 8 divided by tangent 50 is 6.7. And again, there are units, so I'll stick in the units of centimeters. Why am I rounding it to the nearest tenth? Because way back at the beginning, it told me how to round the question. If it doesn't tell you how to round, I'll accept a variety of answers, but make sure you check to see if the question tells you. Okay, yep. You didn't get 6.7? Okay, while I help out here, feel free to try the next one. I'd recommend you always sketch a diagram if you're not given one. So here I'm not given an angle. I'm told, or a diagram, I'm told one angle is 60 degrees, so I'll fill that in. 60 degrees. And the side adjacent, so relative to the 60, this is adjacent, this is opposite, that's hypotenuse. So the adjacent side is 50. I want to know how long the hypotenuse is. Wait, tangent doesn't tell me about hypotenuse. What can I do? Below? Yeah, we can find the opposite side and then use Pythagorean theorem to find the hypotenuse. So we'll start with that. We'll say this is, I'll call my x. So I can say the tangent of 60 degrees will be x over 50. And I'm going to solve that. Once I solve it, then I'm going to stick it into my Pythagorean theorem and have x squared plus 50 squared equals my hypotenuse squared, and we'll solve that. So I'm going to give you a head start to see what you can calculate for this one. So here you can see my calculations. I got an x value of 86.6 and a bunch of decimal places. Keep all those decimal places when we plug it into Pythagorean theorem, and we get exactly 7,500. No rounding required if you kept all the decimal places. And then when I finish off Pythagorean theorem, I discover hypotenuse 100 meters long. Okay, so the handout that I gave you, the first side is calculating angles. The back side is calculating side lengths. I'd like you to do both sides for tomorrow. It's a lot of homework for today, but I would like you to work on that, please. And thank you.